Right, today's topic is Pythagorean theorem, which you have used in many math classes before. It's super important that we make sure we know the parts of the triangle that we're dealing with. Pythagorean theorem is for right triangles. Right triangles are indicated by having a little box in the bottom corner. That tells us that this angle is 90 degrees. The hypotenuse is the longest side of the triangle, and it's always across from or opposite the 90 degrees. So this is our longest side. Okay, that's our hypotenuse. The other two sides, A and B, are called legs. Okay, those are our legs. The legs make the right angle. Okay, so the legs make the right angle, the hypotenuse is across from the right angle. The A and the B values, typically A is the shorter one and B is the medium sized side, but they can technically be interchanged because all we're doing is squaring them and multiplying them. So we're going to look at some Pythagorean triples. Pythagorean triples are when we have integers that work for the Pythagorean theorem. Okay, so the first one, 3, 4, and then our missing one here for the hypotenuse is 5. And if you're wondering how do we get those, we're doing 3 squared because this is like the A, this is like the B, the hypotenuse is like the C. 3 squared plus 4 squared equals C squared. So we're going to say 9 plus 16. 9 plus 16 is 25, and that equals C squared. To unsquare something, we use the radical key on our calculator. The radical button is this one, so we would type 25 and then square root, and we get 5. Okay, for this triple, we don't know this value. We know B and we know C. So this is going to be a little different. We don't know A, we know B, and we know C. So now we're going to square everything we know. 12 squared is 144, 13 squared is 169. To figure out our missing piece, we would subtract the 144 from both sides, and then we get A squared is equal to 25. And again, take the square root, A is 5. Okay, so that's going to be the same process to fill in our missing gaps here with all of these. This one is, you can pause the video and try these and see if you can get them correct. Okay, and then when you start the video again, we're going to have the answers filled in. Okay, so these special numbers, again, are called Pythagorean triples because they're 3 numbers that are integer values that work for the Pythagorean theorem. Okay, so example 1 says determine whether the set of measures can be the sides of a right triangle. So if we say the shortest is A, the medium is B, the longest is C, and we test it out. So if we follow the formula, we've got 5 squared plus 5 squared equals 10 squared. Is this true? So 5 squared is 25. If I add those together, I get 50. Does that equal 10 squared? Our answer is no, it doesn't equal 10 squared. So this cannot be a right triangle. Okay, then we've got 8, 12, 13. Smallest is A, medium is B, largest is C. 8 squared plus 12 squared equals 13 squared. 64 plus 144 is 208. and we're checking to see if that equals 169. It does not, so not a right triangle. C, the smallest is A, the medium is B, the largest is C. So 10 squared plus 24 squared is equal to 26 squared. So we've got 100, not equals plus 576, which gives us 676. 26 squared is 676, so the left side equals the right side. So this is a right triangle. So this would be another example of a Pythagorean triple. Okay. In example 2, we're finding the length of the other leg. It says give the exact answer and as a decimal to the nearest hundredth. So this is our right angle. So we know that 12 is our C because it's opposite. A and B are going to be these two sides. It doesn't matter if you call the 8A or the 8B. It's totally up to you because you can switch the A and the B around. Okay. We're going to square the 8, square the 12, and then we're going to subtract the 64 from both sides. When we subtract the 64 from both sides, we get 80, and then we're taking the square root. So we've got square root of 80. That is an exact answer because I didn't round it at all. As soon as I hit my square root button on my calculator, I'm rounding. So I'm going to say it's approximately. My direction said round to the nearest hundredth. That's 2 decimal places. So this is going to be 8.94. Next one, we find our right angle. We look opposite. That's our C. Our A and our B are 5 and 12. So 5 squared plus 12 squared equals C squared. You might recognize this one from the list that we just talked about. It's on our triples list. We take the square root to solve, and when we take the square root, it's a whole number. So I don't have to round this one. This is my exact answer, and there's no rounded answer needed because it is an integer. Okay, example 4 is a word problem. We have a ladder is 8 meters long, leaning against a building. How high on the building will the ladder reach when the bottom of the ladder is 3 meters from the building? So this distance here is 3. We're trying to figure out how high the ladder will reach. So we've got a little triangle set up here. We know the ladder's 8. We know this base here is 3. This is our right angle because our building and the ground make 90 degrees. We don't know the height. That's what's missing. So in this example, across from the right angle is our C value. That's our hypotenuse. So we're going to say 3 squared plus h for height is equal to 8 squared. Square everything we can, subtract the 9, and we get h squared is equal to 55. So now we're going to have to take the square root. And when I take the square root of 55, I get a decimal. So I'm going to have to round it. And we can just keep it consistent and round it 2 decimal places. And it's going to be 7.42. I'm rounding this to a 2 because the number next to it is 5 or higher. That tells me to round this number up. Okay, our answer is in meters. So we want to make sure we put our unit of measure. Example 5, find the perimeter of a right triangle with legs that measure 5 and 9. So I'm going to sketch a picture. Right triangle, legs 5 and 9. So that tells me those are the two sides that make the right angle. I'm trying to find perimeter. Perimeter means all around the outside. I add them all up. So I need my missing side. That's my C because it's opposite the right angle. So 5 squared plus 9 squared equals c squared. 25 plus 81 is c squared. And then we have to add to get 106. And when we hit square root, it is not a whole number. So we're going to round. And this is going to round to 10.30. So now when I do perimeter, we're going to add up all of our sides. Perimeter is 5 plus 9 plus 10.3. So I'm going to have 24.3, and it's centimeters.